Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. I'm continuing my O-level past paper session. I was doing IGCSE Chemistry 0620 and in my last video I have done paper 62 and this time I've selected 63 for May-June 2024. It's paper 6. Time 1 hour. You all have to answer all the questions. Total mark for this paper is 40. You can use calculator. Notes for use in qualitative analysis are provided in the question paper like this. Let's start the paper. Here's question number 1. A sample of rock salt contains sodium chloride, sand, and mud. Sodium chloride is soluble in water. Sand and mud are insoluble in water. A student obtains dry crystals of pure sodium chloride from a lump of rock salt. Figure 1.1 shows some of the steps the student uses. Step 1, grind the rock salt into small pieces. Step 2, add the rock salt to water and heat while stirring with a glass rod. Step 3, filter the mixture. You can see in figure 1.1, they have shown the diagrams also, the apparatus you need to use in this experiment. A, explain why the rock salt is made into smaller pieces in step 1. Definitely to speed up the dissolving process. So you write to speed up the dissolving process because small size dissolves quickly. Part B, name an item of apparatus that can be used to heat the water in step 2. Definitely you need Bunsen burner for this. Bunsen burner is used to heat the solution. So I'm going to write Bunsen burner. C, name the apparatus labeled A in step 3. What is A in step 3? It's filter funnel. Used for removing insoluble solids from the solution. So I'm going to write filter funnel. Part D, describe what the student must do after step 3 to obtain dry crystals of pure sodium chloride. So in step 3, you have aqueous sodium hydroxide. We need dry crystals of pure sodium chloride. So definitely you need to heat the solution. So I will write heat the solution. First step must be heat the solution to the crystallization point, which means until it becomes crystals. To the crystallization point. Last step, you can use absorbent paper or drying. Use absorbent paper in order to remove any moisture left or dry in air. Question number 2. A student investigates the rate at which hydrogen gas is made when magnesium ribbon reacts with dilute ethanoic acid at 2 different temperatures. Instructions. The student does 2 experiments using the apparatus shown in figure 2.1. We have the figure 2.1. The whole apparatus is given. We have dilute ethanoic acid, conical flask, bung, rubber delivery tube. You are having water, trough, inverted 100 centimeter cube measuring cylinder, and you are also having clamp. Experiment 1. Use a measuring cylinder to pour 50 centimeter cube of dilute ethanoic acid into a conical flask. Use a thermometer to measure the initial temperature of the dilute ethanoic acid and record the initial temperature. Set the apparatus up as shown in figure 2.1, ensuring the inverted measuring cylinder is full of water. Remove the bung from the conical flask, ensuring the delivery tube remains in the measuring cylinder. Add a coil of magnesium ribbon to the conical flask. Immediately put the bung back into the conical flask and start the timer. If the magnesium sticks to the side of the flask, gently shake the flask so that it's washed off the side. Measure the volume of gas collected in the inverted measuring cylinder every 15 seconds for 150 seconds. Record the volume of gas collected. Use the thermometer to measure the final temperature of the mixture in the conical flask and record the final temperature. Rinse out the conical flask with distilled water. Experiment 2. Repeat the experiment 1 but warm the acid by about 15 degrees centigrade after it has been poured into the conical flask and before the initial temperature is measured and recorded. A. Use the thermometer diagrams to complete the table 2.1. So we have experiment 1 and experiment 2. Their initial and final temperature. Initial temperature for experiment 1, it is 25. It is 22. Sorry, it's 22.5. It's 22.5. And the final temperature for experiment 1 is 26.5. So the difference in temperature must be 26.5 minus 22.5. It must be 24.5. For experiment 2, temperature is 39. Initial temperature is 39. The final temperature is 40. If you subtract 39 from 40, sorry, I made a mistake here. You need to take the average temperatures, not the difference. So in experiment 1, we have 22.5 plus 26.5, 49 divided by 2, we'll get 24.5. So for experiment 2, 39 plus 40 divided by 2, we'll get 39.5. This will be the average temperature. B. Use the diagrams of the inverted measuring cylinders to complete table 2.2. For experiment 1, they already gave the volume of gas collected. We have 12, 22, 31, 37, 43, 48, 52, 56, 59, 62. So for experiment 2, the volume of gas collected is, the first one we are having 21. And second one we are having 31, 32, 33. The third one we are having 41, 42, 43, 44, 45. The fourth one we are having 54 here. Then we are having 62. Then 68. Then it must be 75. Then this one 80. This one 84. The last one 88. Part 3. Complete the suitable scale on the y-axis and plot the results for experiment 1 and 2. On figure 2.2, draw two lines of best fit. Both lines must start at 0. Label your lines. You have to label your lines. So for your convenience, I've already drawn this graph. The graph will be like that. So you see for the experiment 1, you shown with a red line. I plotted the graph and we are having best fit of lines for this experiment 1 as well as for experiment 2. For experiment 2, I've used blue color, and for experiment 1, I've used red. So this will be the final graph you will be obtaining for both experiment 1 and experiment 2. Moving to next part. D. Reduce the volume of gas collected between 20 seconds and 40 seconds in experiment 1. Show clearly on figure 2.2 how you worked out your answers. So gas collected between 20 seconds and 40 seconds for experiment 1. So experiment 1, 20 seconds and 40 seconds. So between 20 and 40, we are having 30. It must be 22. The maximum volume collected is here, which is 20. It's 27.5. So for 20 second, at 20 second, how much volume we got? We got 14.5. And for 40, we are getting 27.5. 14.5 and 27.5. Minus 14.5. 13. We'll be getting 13 centimeter gas collected. E. Use figure 2.2 to explain which experiment had the fastest rate of reaction. You have to give explanation. Definitely, if you look at this graph, it must be experiment 2 because you are having more steeper line. So I will write experiment 2 here, and we are getting line steeper. Explanation will be line steeper. Or you can even also write gas volume greater at the end. F. During experiment 1, the temperature of the mixture in the conical flask changed. 1. State how this change in temperature affects the rate of the reaction. You see the temperature they have changed in experiment 1, and what they have changed? They have increased the temperature. They have increased the temperature. So what will happen? How this change in temperature affects the rate of reaction? Definitely it will increase the rate of reaction. So I will write increases. 2. Describe how the apparatus could be altered to minimize the change in temperature. You can use water bath and stand the flask on it at initial temperatures. Use water bath and stand the flask on it at initial temperatures. Looking at the experiment, this is the only way we can do this. This way you can alter it to minimize the change in temperature. The change in temperature will be minimized in this way. G, some gas escapes in short time between adding the magnesium ribbon to the conical flask and putting the bunk back into the conical flask. Explain how the apparatus could be altered so that no gas escapes and the results of the experiment are more accurate. You may draw a diagram to help your answer. What we can do, we can place one reagent in tube inside boiling tube or the flask. Place one reagent in tube inside boiling tube or flask. Tip tube to start reaction. Tip tube to start reaction. You can tip the tube, start the reaction, and this is the way we can alter, so that in this way we don't have any gas escaping from this, and we'll be getting more accurate result. Tip tube will be like that. Usually it's used in cannula. H. Describe one other way in which the results of experiment 1 and 2 could be made more accurate. We can repeat the experiment and determine mean. Repeat and determine mean. Or you can use a burette, because in case of burette you have high accuracy. Or use a burette. In this case, volume will be more accurate. I. Sketch on figure 2.2 the graph you would expect when experiment 2 is repeated using ethanoic acid with a higher concentration. Now you are using higher concentration. So what will happen? Definitely the graph will start from this point, but you will be getting more steeper gradient. And remember, it does not level off or end at the same horizontal line. So we have increased the concentration. You must be getting graph something here like that. It must be like that. This one is for I. So remember these things. Graph should start at 0, 0 and more steeper gradient. You'll be getting more steeper gradient. Last but not least, does not level off or does not end, does not level off or end on the same horizontal line. So keep these 3 points in your mind when you are drawing the graph for this part. Moving to next question, which is question number 3. A student tests 2 substances, solid K and solution L. Test on solid K. Solid K is copper 2 carbonate. They already gave us the name of the substance, which is copper 2 carbonate. Complete the expected observations. A, the student adds about 5 centimeter cube of dilute hydrochloric acid to solid K. Observations. So it's a reaction of copper 2 carbonate with hydrochloric acid. Hydrochloric acid is HCl. We'll be getting what? We'll be getting salt plus water plus carbon dioxide. These will be 3 products obtained in this case. So observation, the common observation when you are getting carbon dioxide must be fizzing or bubbling. The solution made in A is solution M. The student divides solution M into 2 portions. B. To the first portion of solution M, the student adds aqueous ammonia drop-wise until it's in excess. Observations. Now, definitely, this will test the presence of copper 2 plus ion. Here's the test for cations. If you look at the test for cations, effect of aqueous ammonia, where is Cu2 plus? Here is Cu2 plus. You'll get light blue PPT, which is soluble in excess, giving a dark blue solution. So you'll write what? Blue PPT. Soluble in excess, soluble or dissolve in excess, to give dark blue solution. Moving to next part, which is part C. C. The student carries out a flame test on the second portion of solution M. Number 1, state the color of the Bunsen burner flame becomes during the flame test. This flame test is for the presence of Cu plus 2 ion or Cu2 plus ion. It's blue-green. So you are going to write blue-green here. Next part, describe how the student should carry out the flame test. These are the steps you have to follow. So you can write any 2 from these. First of all, you need to make a paste. So I will write, make a paste in dilute hydrochloric acid. Make a paste in dilute hydrochloric acid. Then you have to dip the wire or splint. Dip the wire or splint into HCl, that's hydrochloric acid, and bring it, hydrochloric acid paste actually, the paste is in hydrochloric acid, and bring it to flame, and bring it to flame. Mention the color of the flame, blue or non-luminous flame. Blue or non-luminous flame. Test on solution L. Table 3.1 shows the test and the students' observations for solution L. Solution L was divided into 2 portions. Here's table 3.1. Test to the first portion of solution L, add aqueous sodium hydroxide dropwise until in excess. Observations, a white precipitate forms which is insoluble in excess. Now with sodium hydroxide, we are getting white precipitate and insoluble in excess. It must be of Ca plus 2. So I'm going to write Ca plus 2. To the second portion of solution L, add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. A cream precipitate forms. This is a test for the anions. If you look at the test for the anions, this is a test for the halide ions. When you are going to add nitric acid and silver nitrate. And they are saying cream precipitate. It must be of bromide ion, Br minus. D, identify solution L. So you can write calcium or Ca plus 2. We are getting bromide or Br minus. Moving to last question, which is question number 4. Iron rusts slowly when exposed to water and air. There is an increase in mass when iron rusts as the insoluble solid hydrated iron 3 oxide forms. Cast iron, mild steel, and stainless steel are all alloys that contain iron. Plan an experiment to find which of these 3 alloys rust most quickly when exposed to water and air, including your answer how the results of the experiment will show which alloy rusts most quickly. You are provided with powdered cast iron, powdered mild steel, powdered stainless steel, and common laboratory apparatus. So you can write, let's see the marks. The total mark for this question is 6. So you can write any 6 points from these. Any 6. So you have to start with same mass of iron and steel. Start with same mass of iron and steel. Now, this will decrease or reduces anomalies, and it also increases the accurate result. Next, you have to place in a suitable container. Place it in a suitable container. Now name the container you are using, like you can use beaker here, or you can even use test tube. With equal or same volume of distilled water. With equal or same volume of distilled water. It's very important you will use distilled water. We need pure water. We need water and oxygen for the process of rusting. The next one, leave it for a suitable period of time. For a suitable period of time. Filter out the iron or rust solid. Next one, filter out the iron or rust, which is definitely the solid one. Next one, what we can do, dry the solid. You can mention, you can even write iron, you can even write rust, or you can even write residue. Note down the mass of solid, that is iron or rust or residue. Solid, which can be either iron or rust or residue, with the highest mass has rusted most. Are you going to get it? You will get it by doing this calculation. In order to calculate the change in mass, final mass minus initial mass. This will give you a better idea which one has rusted most. This will also reduce anomalies and increases the accuracy of this experiment. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.